Okay, hello and welcome to lesson 2 on binomial expansion. This is your facilitator, Mr. Alfred Gordon. In today's video, we shall be looking at the binomial theory, that is the general form of the binomial theory. Okay, but let's have a quick recap on the combination approach. Okay, now we said in year 1 that for a plus x power n, by using the combination approach, you remember that we said that for n combination r is equal to n factorial all on n minus r factorial r factorial. Okay, so for our first term, that is n combination 0, then we have a to the power, the highest power, whilst x becomes the lowest exponent. Okay, together with n combination 1, a to the power n minus 1, so a reduces power by 1, and x increases power by 1, plus n combination 2, a reduces power by 1 again, so we have n minus 1 being n minus 2, whilst x increases power to power 2, plus n combination 3, a to the power n minus 3, and then x increases power to 3. So the series continues to the last term, n combination n, a to the power n minus n, and then x to the power n. Okay. Now, as you can see, the summation we have here is the summation for r is equal to 0. So as we can see in our combination, here r is equal to 0. That's the beginning. And it's ending at r is equal to what? N. But in all, we are doing n combination r. So in this one, we are doing n combination 0. We are doing n combination 1 up to n combination n. And we have expressions as a to the power n minus the particular r. So when r is 0, we have n minus 0 up here, okay? And then when r is 1, we have n minus 1, okay? And then we have the x also to the power that particular r, giving us this summation. So for any non-negative integer n, a plus x all to the power n is equal to the summation r equal to 0 up to n, and this is the combination, which is the same as n combination r. Okay, then we have a to the power n minus r, we have x to the power r. Now this is usable, okay, when the exponent is a non-negative integer. Now, to obtain a standard form where we can use for all exponents, then we consider expanding all our coefficients in combination form. But remember in our previous lesson, lesson 1, that for n combination 0 is equal to 1. If you have not watched that video, go back and watch that. Then n combination 1, we have obtained n, okay, and then n combination 2 was n minus 1 all on 2 factorial, as well as n combination n was also 1. So to expand this, we can see that n combination 0 is 1, okay, so we will have our combination expansion up as a plus x all to the power n. Okay, so up here n combination 0 gives us a 1. Okay, then we have e to the power n, but we also know that x to the power 0 is also 1, plus the coefficient here is n combination 1, and we know n combination 1 is n. Okay, we have n to the power n minus 1. Okay, and we have x to the power 1, okay, which is x. Okay, so let's write it as x, plus for n combination 2 gives us n together with n minus 1, okay, all on 2 factorial with the expression e to the power n minus 2 and x to the power 2. Now this continues to the third term, which will obtain, okay, n minus 1, we have n minus 2, also on 3 factorial with the expression e n minus 3 x to the power 3. So this continues up to the last term, where we have the last term n combination n is 1. We have e to the power n minus n, which is e to the power 0, which is also 1. And we have x to the power n. So by simplification, we have this to be e to the power n plus n, e to the power n minus 1, okay, be with me, plus n minus 1, all on 2 factorial, e n minus 2, x to the power 2, plus n minus 1, n minus 2, all on 3 factorial with expression e n minus 3, x to the power 3, up to the last term, which is x to the power n. So this is a general binomial expansion that we have here, the general binomial expansion. Now we shall follow through to obtain the special case where e is equal to 1. So stay with me here. So the special case, that is in the expansion we had earlier on, we said x to the power n, x plus x to the power n is equal to e to the power n plus n e to the power n minus 1 x plus n minus 1, all on 2 factorial with the expression e to the power n minus 2 is x to the power 2 plus n minus 1 n minus 2, all on 3 factorial with e n minus 3 x to the power 3 up to the last term, which is x to the power n. For the special case, we are considering a case where e is equal to 1. So when e is equal to 1, this expression here becomes 1 plus x all to the power n. So at this point, all our e's are going to be replaced with 1 or substituted with 1. So 1 to the power n will give us a 1 plus, okay, we have n. This 1 to the power n minus 1 is also a 1. So we have x plus, we have n minus 1 all on 2 factorial. In this case, okay, 1 to the power n minus 2 is also 1. So we are left with x squared plus n minus 1, n minus 2, all on 3 factorial. Okay, and then a will do, we have 1 to the power n minus 3 is also 1. So we have x cubed plus, okay, after the last term, where we have x to the power of n. So this becomes a special case where n is equal to, where e is equal to 1. Similarly, for 1 plus minus x all to the power n, then we replace all x's in this expression with negative x. So for 1 minus x all to the power n, we shall have 1 plus, now we have n, and then we have minus x. So in place of x, we replace minus x plus n minus 1, all on 2 factorial with minus x all squared plus n minus 1, n minus 2, all on 3 factorial. Then we have minus x all to the power 3 plus up to the last minus x to the power n. Okay, now stay with me here. With this we have 1 plus minus, because this will give us a minus nx plus, now the square of a negative is positive, so we have n minus 2, n minus 1 all on 2 factorial, and we have x squared. Okay, now the cube of a negative, okay, that is to see that we have a negative x multiplying negative x multiplying negative x. Now with this, we have negative x by negative x gives us a positive x squared, multiplying a negative x to give us a negative x cubed. Okay, so be very careful with all the exponents. We have minus, okay, we have minus n, and we have n minus 1, we have n minus 2, all on 3 factorial with x cubed plus up to the last day, okay, and I'll write this as minus x to the power n, okay, depending on the power of n. So when n is odd, the expression here becomes a negative, and when n is even, the expression here becomes positive. So be very careful with negatives. Okay, so I'll pause the video here so that we shall apply these special cases and the general expansions to expand binomial expressions in our next video.